Hello, I'm Emiralp İlgen. I'm a student at Bilkent University and my department is computer engineering. In this semester, I'm taking the Physics-101 course, and in this video, I will explain my Physics-101 project to you. The aim of the experiment was to examine the relationship between the amount of compression of the spring and maximum velocity of the object in the simple harmonic motion. The maximum velocity always appears at equilibrium point in simple harmonic motion. First, I used a frictionless air table, a spring, different masses, a pen, a stopwatch, and a string in the table. Before starting the experiment, I controlled the ground of the frictionless air table if it's flat or not. To measure the spring constant, I attached a known weight to the spring and measured the extension of the spring. Then, using this extension, I calculated the spring constant using Hooke's law formula. Next, I proceed to the second phase of the experiment. In this phase, I first attach the spring to the ground, and then I attach the weight to the spring. I compress the weight by about 4 cm and release the setup. Afterwards, I measured the maximum velocity, which was the objective of the experiment. During velocity calculation, I used the Lagrange numerical formula. Then I repeated the experiment for different weights. In order to use Lagrange formula, I choose 5 consecutive points around equilibrium point. Then I measured the time when the mass passed from these points. After these measurements, I calculated the maximum velocity of the mass with using Lagrange numerical formula. When comparing the expected results with experimental results, I encountered with an error of around 10%. I believe this error mainly stemmed from external friction forces. However, despite this error, the experimental results were still useful in terms of observing the relationship between the variables like velocity and the mass. And the relationship was the velocity is likely equal to the square root of the 1 over m. Thank you for listening me.